Storm Runner. This ride has a very impressive takeoff, experiencing a large acceleration at the beginning. It also features a 46-meter ride to the peak of the top hat. Start by making the predictions. You could do this before you arrive at Hershey Park if you are familiar with the ride. You will only need a stopwatch for this ride, and you do not have to ride the ride itself. Of course, the fun is riding it, but you don't have to. If you don't like roller coasters, this is a good lab to do. For safety reasons, you can't take an accelerometer on the ride. Ride operators won't let you hold anything, especially an accelerometer. Stand off to the side where you can see the train's initial takeoff. The train comes out of the station very slowly, and then it stops for an instant just before it takes off. Start by using a stopwatch to record the time at the start. Start timing as soon as the train starts to move. Stop timing as soon as the train reaches the bottom of the top hat. This means stop timing as soon as the train gets off the level section of the track and starts to ascend. Take at least 5 measurements. Then pick the 3 that are the most consistent and average those 3 measurements together to get the time. If you aren't accurate measuring the times, you won't do very well in this activity. Once you are confident that your time is correct, use this value to perform the calculations on the lab. Show your calculations on your paper. You will calculate the average velocity of the train using the equation displacement divided by time. The displacement is the number for the horizontal run during takeoff from the engineering specifications. Once you know the average velocity, you can calculate the final velocity using a different kinematic equation. The initial velocity is 0 at launch, and you know the average velocity. Then you can calculate the acceleration in meters per second squared once you know the final velocity, initial velocity, and time. The last calculation in this section requires you to convert this number to Gs. Remember that 1 G equals 9.8 meters per second squared. Next, you need to find the velocity at the peak of the top hat. You know the length of the train, so you just have to calculate the time for the train to pass a point. Pick a point at the very peak of the first hill. Start timing as soon as the front of the train reaches that point, and stop timing as soon as the back of the train reaches that point. Repeat this 5 times and take the average of those 5 measurements. If your results aren't consistent, take additional measurements to be sure your results are correct. You now have all the measurements that you need. Perform the calculations and answer the questions. Or go take a ride on Storm Runner and do the calculations while you wait in line.